Good morning, everybody. Hope everybody's doing well. I wanted to create this lecture video on the concept of classes and objects, right? I mean, so before, as I'm talking, I'm going to open my IDLE, right? So when I, 25, 30 years ago, when I started programming in computer science at college, I mean, the language we used was C. And C was a very tedious language. It has a very strong syntax. I mean, it works really good though. But then Java and C++ came about, and when C++ came about, it was really, really famous. I mean, it became really hit, and the reason that happened was because C++ introduced the topic of objects. Being able to do things in little pieces and then join them together. And I remember the example they were showing. I remember watching a video, and this was 25 years ago, whatever it was. I remember the example was an orchestra. How different folks in the orchestra, they play different instruments and whatnot, and then it all comes together as beautiful music. So I remember that, and that's how the whole concept of objects and classes is, right? It allows you to group things together that belong in something, right? Group things together and belong in something, and then and then be able to use them when needed, right? That's how orchestra is. I mean, people don't play full, all the time, unless when they're supposed to do their music, right? That's when they play. So that's how it makes it beautiful, right? Likewise in programming, you put things in different classes that do various things, right? And you use them only when needed. All right. So what would this be? This would be, let me name it. This is what this project. This is classes and objects, right? Okay, so I'm going to give you an example here. Let's just say I want to capture information of a student, right? So a student basically name has a name, and here I'm going to put in, well, let me just put a name, and then let's put John here, John Bell, right? A single quote. I'm sorry, single quote, and then the age of John is also, let's just make age is equal to 18, and then also employer, like a school employer, of course, employer is equals to, let's just put AWS, right? AWS, and then I want to have another one as in pay rate. So you see, sometimes, I like, you see other programmers when they name their variables, they'll put underscore here, pay rate, which is okay too, but I've just done it this way. It's called, I think this is called camel casing or Pascal casing. I think camel casing, right? Pay rate, and that would be 45.67. All right, so that's a student, right? And if I want to print this out, I can simply say print, right? I'm a student, right? And then here, just making it easy, name, age, employer, and pay rate. All right, just simple stuff like that. Now, so that is one student, and let me put student number one here. Okay, student number one. Now, if I wanted to use some of this silly code in writing program for the school, then I have to have variables like this, and a student has only, this is only four properties of a student, 4 items that describe a student. What if, I mean, there is 20 or 30, even more attributes that describe a student. Some of the ones I can think is, date of birth, right? Date of birth, right? And I'm not sure date of birth. I think in Python is you have to put it that way. Let me just use it that way. 12. Let's just put 206. Right, and I mean, there's all kinds of things, right? I mean, not just only 4, but for today's purpose, I'm just using 4 properties, right? This could be 40, So, and if I want to do another student, right, what that means is that I have to go here and do, I can reuse those variables and say name is equals to, right, Mary Jones. Why am I using double quote? I mean, double quote works fine, but I'm just, I guess, all the other languages use double quotes. Mary, and then age is equals to 19, right? Employer is, let's put Mary at Google, of course, right? And then pay rate is equals to 67.9, right? So that's good. Now, if I want to print this second student out, I have to do the same thing, okay? I have to do the same thing. Now, the problem with this, and you see, if I had to go ahead and do 10 of these, then, I'm writing a whole bunch of code, right? I'm writing a whole bunch of code that is just a ton of code that could be efficient, right? That could be very efficient. So what we're going to do is that we're going to look at the concept of a class, right? What that means is that how do I, instead of me writing this code over and over again 30 times, how do I create this code one time somewhere and I'm able to use this over and over again, right? So that's the, you can do it in a function, you can do it in many ways, but the most appropriate or the proper way would be to use a class. Now, class basically means, like when you program Java, right? Everything in Java is classes, everything, right? Every piece of code is a class. And what that means is that, you put attributes that belong to that entity into that class. Okay, so let's just go and create, let's just go and create this. So I'm going to take this out. I'm just showing this up to you. So in order for us to create a class, what I'm going to do here, and I'm going to say, use the keyword class, right? And we're looking at student, right? And make sure you have a colon, right? Colon, and then, so that's how you create a class, right? And, I can put a pass here. That means I'm telling Python that, hey, I'm going to fill this up later, right? But I don't need a pass here. I'm going to fill this up now. So, simply what happens is, you need to have I have a student class, and I want to go ahead and put some attributes, right? Properties or attributes that describe a student. So the first one I'm going to say is name, right? Name, and I can, name, I can make this equals to, as a default. Let me just make it, I wonder if I should make an empty string. No, let's just take this out, right? So, when you write Java code or C++ code, you have to have properties, right? You have to have variables that will hold those values. In Python, it's a little different, right? I don't have to say here name is equals to empty string, right? I don't have to say age. Actually, I do, but it's not required. I can do it that way too. But what I'm saying is you can avoid this typing, right? That's the whole goal of learning Python, is you can avoid a lot of typing. Okay, I can put that in what I call, or what we call, is a constructor, right? Constructor is where the constructor is the first method that is called when when this class is used, right? This is the very first method or function you have to use. So the way it's done is, normally in C++ or whatever, you're going to do something like student with a, make sure the names match, right? In Python, it's not like that. In Python, you have to use the define code, and then use a double underscore, right? Double underscore in it, and double underscore again, right? So that will, this is the constructor, right? Now the Python compiler knows that this is the constructor, right? Spelling correct? Okay, so now the other thing you got to understand is that in this constructor, whenever you do that, you have to provide a code here. And any function that you call in Python, any of these functions that you call, right? You have to provide a keyword which is called self, right? Which is called self. And self is like a pointer in C++ that points to itself. Likewise, in Python, self points to itself, right? This only needs to be provided here, right? You don't have to, it seems like that is coming in as an argument, but when you run this, when you use this student class, you don't have to provide this as an argument, as an argument, right? It seems like it's coming in as a parameter. You don't have to provide as an argument. I'm going to show you when the time comes. All right. So, let's just say when I use this student when I use this student object, right, student class, right, I need to provide some information. I'm going to provide name, age. What was the other one? Name, age, and then oh, I forgot what else. Let's just put major, and then pay rate, right? Pay rate. Let's just change. Okay. Look and put pay rate, hourly pay. Let's just go hourly pay. I just want to have a double here, right? So what this means is that these values are coming in when I use this, when I initiate, instantiate an object of this class, then I have to provide these values, right? So the way I'm going to use that is now you have to say self.name is equal to name, right? Now, basically, this value is right here, and that is a variable name that I didn't have to declare, but it's declared now, right? And I can say self.age is equals to age, self.major is equals to major, self.hourly pay is equals to hourly pay, right? Now, that is it, right? That is it. Now, I'm going to also, let me see if I could look for a code for Java student class. I want to see, I want to show the difference between, I'm just pulling something up on the web, right? So I'm pulling something up on the web. You watch this, right? This is a Java, right? This is a Java student class, right? And basically what it is that you see, in order for you to do that, you have to have a public class, right? And then you have to have the variables, right? And then have a constructor right here. So all of these, right, is equivalent to what we have done on the screen. Okay, so now my student is done. No, it's partially done, right? Partially done. What I want to do as well is that I want to go ahead and write a function here, right? Function here in this class that will print those values back to me. Okay. So, and the way we're going to do that, as we've learned before, the way you write function is you start with the word def. So here's the trick. Understand this. If I write my my function declaration from there, say display display, right? Display. There will be a problem because you see, Python looks at the scope, the starting and the ending block using tabs, right? So this is not inside it. Now this will belong to it because you see all this tab, that kind of determines which line of code belongs to this class, right? That's how, instead of curly brackets, like other languages do, Python, we use tabs. All right, so this display, so what am I missing right here? What am I missing? Well, one thing I'm missing right away is that, like I said, any of this function needs to have a self. If you're going to reference any of the properties, you need to have a self. And here, what I want to do is that I simply want to say print, and then I'm going to say print. I'm going to say student details, right? Colon \n. Cut that out, right? And then I'm going to say print. Now watch what I'm going to do here. I'm going to say self.name, comma, self.age, comma, self.major, comma, and self.hourly pay. Oh, I just found a spelling mistake. Right. So that now what I've done two things here. I've created, actually done more than two things, but what I've done is that I have a class called student, and then I have created some properties or attributes of a student. Okay, could be more, but in this case, let's just say this is what I need. And then I've also created a method in the student class that will print this out, print these values out to the user. So now that I have these, right, now that I have this, what I can do, let's just go ahead and see how I'm going to use this, right? And I got some extra spaces here, which I'm going to take it out just for, and this is our put right here. This is our student. Now, do you see how um, you know the items that I have, the attributes that I have in this code describes a student. It belongs to a student, right? It belongs to a student. So that is the whole idea of objects and classes, right? Actually, that's the whole idea of classes, right? Now, this class is not an object yet, right? When I use it, then it becomes an object. So sometimes don't confuse yourself. This is a class, right? This is a class. When teachers would, instructors would, sometimes they say objects or classes. It's the same thing, right? But this is a class. It's not an object yet. Okay, so in order for me to use this, what I'm going to do here, and I can say I'm just going to use object, right? Just to show you what's going on. Object is equals to right, a student. Okay, now there is I'm creating a new instance of of a class, new instance of the student class, and then so since this has a constructor, I need to provide the arguments, right? Now, like I said, the self argument does not go here. Everything else does, right? The self does not. So you don't have to provide the self, you have to provide everything else. So I'm going to put a name here. Let's just put John Bell, comma, 34 major accounting, comma, hourly pay in 9, right? So now that is an object. Now what I can do, so now I have an object I have an instance of an object, right? I have an object. And then I can simply use object dot display, right? Display. That will call this method. This will call this method, right? And it will go ahead and print this stuff out, right? And then, right, and then that's it. So I'm going to save this, and I'm going to run this out and see what happens. Okay, so run this code out, and you see it kind of print some things out here, right? Maybe I don't need this new line at the end. Save it again. Let's see if we can print it out. Right? I have my student details here. So let's just say I want to create another student. Okay, what I can do in this case, I can say student 1 is equals to. So the name on the left, this is a variable name. You can put anything you want to, right? You can put anything you want to. Just a variable name. Let's do Mary Jones. What number? 23. And then this is a math major. Math major, and what is the number? Pay. Okay, Mary Jones, and then I can say student 1. Student 1 dot display. Spelling correct? Display. Okay, now running this up. Right, so you see now it's printing details for Mary as well as John. So the whole goal is that I have created this 10 lines of code, right? I've created this lines of code, and I can reuse this as many times as I want, whenever I want. All right, just like the example of an orchestra that I mentioned to you, right? I can use this as many times as I want. So this is the whole idea of creating objects. It really helps to make sure that that your code is organized. So let's just say in here, right? Let's just say I wanted to calculate pay, right? I wanted to calculate pay for student. So I have the pay rate for everybody. What I'm going to do, I'm going to provide another method here, right? I'm going to provide another method and call it DEF. Right, I'm going to say get pay or calculate pay. Let's just go to get pay, right? Let me say calc. Yeah, maybe calc. Okay, calc pay, right? Of course, self as always self, and then I'm going to put hours, right? How many hours did somebody work? And then here I can say I can either send that value back or I can just print it. So for now, let me just let me print it out. Let me print this value out. So basically I can say print, right? I can say student pay for hours, right? And then here, print, I can put them all together and I can say self dot hourly pay times hours, right? Simple as that. Now, when I run this, I mean, nothing's going to happen yet because I haven't called this function yet, right? So here I can say object dot calc pay, and that takes some value, right? And also for Mary, I'm going to say student1 dot calc pay, and that would be, let's just put 30 here, all right? Save this one and then run this, right? You see there's some values coming in, right? Values coming in. Now, how do I, I don't like the numbers coming in here. How do I shorten it up? How do I round it off? The way you can do that is you can simply do, print. You can do in Python, you can do a %.2f, which means 0.2 means 2 decimal places, round it off to 2 decimal places, and f means it's a double, it's a float. I mean, it's a decimal number, right? And percent means, what it means is that whatever value you got, right, bring it and put it over here. So this is the format you need to write this in. Well, let me just try it first and make sure this runs the way I'm waiting it to run. All right, so oh, percent, what am I missing now? Percent f. I was pretty sure. I don't think it's printf here. Oh yes, I forgot. So this basically needs to be a ampersand, right? So what it needs to be done is that, I like, this is how it's normally done in C language, and that's where the whole concept of %.2f came, right? That simply means that round it off to 2 decimal places, and f means that in this argument list, the first value coming in would be a double, right? So let's just say I wanted to, produce, I wanted to put something else here. I can put, since I'm here, I didn't plan for this, but I can put here %d. Actually, I can say hours %d, hours, and then I can say pay rate %f, and then I can say total pay. Let me put it together, right? Total pay in a colon. So in this case, I'm going to take these things out here on top because just one, all right? Student pay for, and then I can put a self dot name, right? Makes a little readable of what's going on. Okay, so now you see, okay, what I've done here, total pay, I got to put a %.2f, right? So you must be asking, why is there a %d, right? %d means in this argument list, after the percent here, right? In this argument list, which I only have one right now, the first argument would be replaced here, right? And the first argument I'm going to replace is self dot, actually not self, hours, because hours is what's coming here, right here. Hours, the pay rate would be self dot hourly pay, right? And then there we go. So if you have 3 of these, right? 3 of this percent in the format, you need to have three elements in your argument list. All right, looking better. If I expand this, it's going to look a little bit better. See that, right? 2 decimal places and whatnot. But see, anyways, the cool thing here is that if I want to do anything in relation to the student, right, I can just do it in the student class. I can have all these lines of code, all right, all these lines of code, and I can just call a method like that. I can call a method like that, right, and it will run it for me, right? Okay, now let me see, right? So you will hear me say sometimes, you will say methods and functions, right? And it's funny because there's always a confusion, right? There's always a confusion. What is a method? What is a function, right? And the problem is because in C and other languages, right, method was something that never returned a value back, right? And function was something that always returned the value back. So that's how it started. But now, right, the difference between method is and function is that these are actually methods because they belong to a class, right? In order for you to call a method, you need to have an object. You need to put a dot here, the dot operator. You need to use the dot operator, right, in order for that to happen, right? Functions, you don't. Functions, you just call it, right? You just call it. So these are basically methods. So in order for you to call the method, I'm glad I remember this because you need to use the dot operator, right? You need to say dot, use the object and put a dot and call this method display, right? Likewise, dot calc 40, right? Providing these arguments. All right. So now there's that. All right. Let me see what else do I have in my note that I want to take you through, right? This is how you instantiate, right? I'm hoping I'm writing the correct spelling here. Instantiate. I think that's the spelling, but it's called instantiation, right? Instantiation. I'm hoping the spelling is correct, but so that is that's how you create a new instance of an object, right? Okay, let me move here, right? We know how to write functions and call them. There are many great projects out there that deal with Python classes and objects, and this is the basic, right? As long as you know how to define a class, how to have a constructor, right? How to have methods. So let me create another method here. And what I want to do here, let's just say, in this case, I want to do a, where am I, right? I'm just creating a method here. And let's just call it, because I want this method, you can see how Python methods take in parameters, okay? And you see how they do something in it without returning it. So this method that I'm writing, I want it to send something back, like return a value back, right? Return the value back. And okay, I know what I'm going to do. I'm going to say, this is weird, but hey, I'm just going to make something up. ES2 retirement, right? Retire, which is I'm just making something up here. So ES to retire, and then basically I'm going to say return, right? Let's just say 65 is the retirement is 65 minus self.h, okay? H, and then in my code, right? I can, I like, normally when using a classes, I like as much as possible. I like, when I call a method, I want everything to be done in there, right? As much as possible. I don't like returning things back because it creates you have to go through an extra step and say, like this, es is equals to object dot es to retire, right? You have to do this extra step sometimes, right? And then you can say print IRS, or the other thing you can also do, taking a shortcut route, you can say print string1 dot es to retire. Of course, I missed a thing here, right? So avoid as much as you have to in such cases, unless you have to send something back that will be used for another calculation. Then you go ahead and do it, right? But as long as you can contain everything, keep everything in the class. All right, let me check if this is working. Right, so it's giving me 4231 here, which I believe it's okay. Hopefully it's correct. Now, how do we access, right? How do we access a like these properties? These are this is a name, age, major, right? These are basically properties. What if I want to print, from my code right here? What if I want to print? What if I want to print one of those attributes? Okay, what do you want to print? So what we can do is that the proper way to do it according to the the programming concept is, let me try this. So I'm going to say print, right, student one dot name. Okay. And, so, I'm going to take this out because you guys know what's happening. So I'm just reducing the amount of stuff it's going to print. Okay. So hopefully this will print is student.name. Let's just see what happens. All right. You see that how it goes ahead and brings me the student.name, right? So next question is, right, in most programming, normally you're not able to access a property just like that straight away, right? You're not able to access, right? In order for you to do that, what you can do, right? You can do a couple of things here. You can write a function, a method that will return a name, right? That would be good. And then that's one way to do it, right? The other way you can do that is by actually, I'm gonna talk about that a little later. How do you go about making the attributes that you have in your code protected, right? How do you safeguard this? Because in whenever you have a class, you don't want to allow somebody to access anything directly. You only want them to access things that you have allowed them to do. All right. So let me look at that. Actually, let's just go later. I want to go according to my lecture plan that I have. All right. So we know that. We know. Now you can do other things too, right? You can, in here, let's just say you can have some attributes here too. And what I mean is that you can set something like year in school is equal to 0, right? So that means as soon as you create a student, the year in school will be 0 right away, right? That'd be 0. And then you can basically, you can do many things with it. And in this case, if I wanted to, I can have another method here to set that up. I can say define set year in school, because that type of thing normally happens later, I believe. All right, like I said, you have to provide a self, and here you can simply say self dot year in school, right? Everything is self dot school. I mean, self. You have to. I mean, all properties need. All of these attributes need to have access through the self, because self is where it's holding to. Okay, so that should be. I'm hoping that should be good. It's not doing anything, but it's okay because I haven't told you to do anything. Now, another thing is, it's not very common though, but it's good to know. It's good to know. You see, this is a constructor, right? This is a constructor right here, right? What does that mean? What is a constructor? Constructor means I'm creating, this class, this code that I have is unusable until I create an object of this class. When I say that, that means I'm using some space in the memory, right? I'm using this, I'm putting this in memory, in use now. So, another concept that normally comes into place, when you have a constructor, you also have to have a destructor, right? Creating it and destroying it, right? And the weird thing is that when Java came about, and I mean in C++, you have to deallocate everything that you allocated. But when Java came out, Java took care of this thing as part of the garbage collection, right? It's called garbage collection. So it's good to know that sometimes you have to, I mean, I have honestly, in all my programming, I have never used a destructor, but the concept is there, right? And the way it's done is that it takes you back to very similar to what we have as a constructor. This would be a delete, and you put self, and here you can put just a message, say, hey, time to delete the object. You don't have to put that, but that's what it means. And nowadays, all these compilers and stuff, they already know when the program shuts down, to remove whatever it was using in the memory. The memory management is much easier now. And the way you're going to call that method, right? The way you're going to use this delete is basically in the student. You will say delete student one. right? And then hopefully it's gone, right? Hopefully it's gone. So, you know, after that, even if I go ahead and do a, let's just say I want to do this after that, after deleting the object, right? Now, I hopefully it gives me an error, right? Hopefully it just says something's going on, right? And something is going on because student doesn't exist anymore, right? So that is that. Let me see what else is important. So the other cool thing about, you know, about programming is that this student, right, student class that I have, you don't see it, but there's a concept of inheritance, right? Inheritance means to borrow or use methods and attributes that's defined somewhere else, right? And I'm going to hopefully my screen, oh, it's my lucky day because sometimes this doesn't work for me. OneNote. I'm going to explain to you what that means, all right? So what it is that the whole idea of inheritance, right? So, you know, you see a class. Class could represent anything. And when I say anything, student, employees, person, courses, sports, vehicle, houses, jobs, anything you name it, you could write a code. You could create a class for it, anything, right? And the whole goal is that, you know, that anything that you got, it has attributes that defines it, all right? Just like vehicle, okay? Vehicle has attributes, draw, right? Vehicle has attributes. So I'm going to call vehicle here, right? Vehicle has attributes. And what describes a vehicle? A color, right? Color, make, model, right? What else describes a vehicle? Color, make, model. Maybe let me see, a license plate, right? Let's just assume that, well, license, I'm going to take this out, and there's a reason I'm going to take it out. So color, make, model. All right, so that's a vehicle, and more things will come up here, right? And so how about a car, right? When I'm, and like I said, anything could be a class. How about a car? Okay, what attributes describe a car? Okay, there is a you know, maybe engine size, right? Engine. That means whether it's a 4-cylinder, 6-cylinder, whatever it is, right? Number of doors, and whether it has a you know, sedan or hatchback, whatever it's called, sedan, right? So there's a car. How about a truck? Truck has, you know, bed size. How big is the bed size? Is it a 4-wheel drive? Okay, and then I'm not sure what does it describe? Oh, does it have a tow, right? A tow package, tow hitch. Okay, now so you see that also a boat could be one, right? A boat is a vehicle as well. Boat, right? Boat would have a hull size, right? I'm not sure. Maybe fishing. I don't know. Does it have fishing? I'm not sure what it's called, but or not even the skiing. You know, the skiing hookups or whatever it's called. So I'm just making stuff up here. Okay, ski hookups, right? Hull size, ski hookups. And then what other things is a vehicle? What other things could be a vehicle? We have well, okay. Now, since I'm going to make one here too, okay? Since I should have planned for this properly. And then you have, of course, a bicycle, all right? Bicycle. What kind of things describe a bicycle? Speed and type. Type is like mountain bike or whatever it is, right? But you see, right, all of these, the items that I've listed here, right? Sedan, right? For a tow package. I mean, cars have tow package too, but let's just keep it to ourselves. Bed size too, hull size, speed and type, right? All of these uniquely describe that individual class, individual entity. But all of these also are a vehicle. Do you agree? All of these are vehicle. right? All of those are vehicle. So what I'm saying here is that you see these classes that I put in, number 1, number 2, 3, and 4. These 4 classes that I'm going, that we're talking about, they all inherit from vehicle. That means all of these properties, right? All of these properties also belong to all of these, right? All of these. That means truck, if the truck is inheriting from vehicle, that means the truck can also use the color, make, and model properties or attributes, right? Same thing with a car. If I make the car inherit from vehicle, the car will also be able to use the properties in the vehicle, right? Just like in a normal language, we talk about child and parent, right? Child and parent, how child, a child inherits attributes of a parent. Likewise, these ones, this is a child, right? All of these are children or child, and this could be a parent object, right? Parent object. So these are basically inheriting attributes from the parent object. Isn't it funny? I used 3 different colors of pen to make the same arrow. So hopefully this makes some sense of how inheritance works. And I think all right, so student, I can do that with student, but I want to use something different, right? Let's just use the vehicle example, right? So this stuff I'm gonna I can just move it down, right? I can just move it down here. So first thing I'm going to do, right? I'm going to create a let's just think about, always when you create, you got to create not always, but it's good to create the parent class, right? The parent class. I'm going to put here parent class, right? Parent class. And then let's just put a class vehicle, right? Class vehicle. And then simple here, I'm going to do a, I don't like putting I don't like putting attributes name outside of it. I always like putting them under the constructor, right? So define double underscore init, double underscore, this takes a self, right? And let's just say vehicle has a model, make, and color, right? 3 things, other things too, but let's just keep it short, right? So self dot model is equals to model, self dot make is equals to make, and then self dot color is equals to color, right? That is good. Now I'm just going to keep it for the and then here I can put another definition function and say describe vehicle. Of course, this takes self as well. Simple as that. Print. I'm just making a shortcut type of thing here. Self dot model, self dot make, and self dot color. So my vehicle is all done, all looking good, right? Now what I'm going to do is that I'm going to create that car, right? The car. So I'm going to say here class. Let's just instead of class is okay. Truck is better. Truck. And now in order for me to tell the Python interpreter that this truck is inheriting from vehicle, you got to put this vehicle here in this parentheses, right? You have to put vehicle like that. That tells them that this truck is inheriting from the truck is inheriting from the vehicle. So define, right, init underscore, and here I'll put self. What did truck had? Truck had a bed size, and I'm going to say is has hitch, and is 4-wheel drive, uppercase, right? All right, so that is looking good, right? That's looking good. So now I got that. What I can do is, all right, that is good. So now I got that, right? Colon self dot, better copy this thing over. Copy this thing over. Self dot sh. Copy this over as well, equals to sh. And then full drive. All right. Okay, so that is now let me think what else we want to do here. It's full drive. All right, so now let's go ahead and see if we can use this, right? We can create something out of it, right? We can create something out of it. Okay, where did my cursor go? Right here. All right, so all right, think about something though. In order for me to, this vehicle class, this is like a parent class. It's like behind the scene, okay? Behind the scene that provides attributes that is used by several other vehicles, several vehicle types, right? So I would hardly call this directly from anywhere. You know how in my student class, I have a student here, right? So what I'm saying is that I would hardly have to create a vehicle instance outside of this class, right? So that's it's kind of in the background in the behind the scene. We're not even seeing it. However, when I use the truck class, I'm going to use it. I need to provide these values. I need to provide these values to the truck class because the truck has this, right? I mean, the truck needs this. The truck needs the model, make, and color. It needs all of these. So, right. But you see, well, actually, I'm going to take this out. I'm going to show you what will happen without it, right? So I'm going to take this out. All right. So let's just go and create our truck class. I'm going to say truck1 is equals to truck, right? It needs a bed size, which is, let's just say 8, right? Oh, 8 would be too long, right? Maybe 6. H is true, and its full drive is false, right? And then I'm going to say, well, it'd be good for me to have another function here called maybe describe. I should have another, just for me to see that truck self, right? And simply print self dot bed size self dot sh, right? And self dot, and of course you can change the true and false to something else, but this is I'm sure you guys know what I'm trying to track information, right? And track information, and then it's okay. So true and false, and then here I'm going to say truck1 dot describe truck. All right, time to delete the object. Take this out. This is all causing a big problem now. And then also what I'm going to do, comment all of those out. 1, 2, 3. Comment all of this out. So no unnecessary print will happen. All right. So I have a bed size 6, and then has a hitch and has a hitch in it's full drive. Okay. So, but however, I don't see, right? I don't see the model, make, and color. I want to see those too. And you see, when I'm creating an instance of my truck class, I'm not providing those. Somebody's got to provide it, right? So how do we provide it and how do I print it? So the way it will be provided is you have to provide that in the constructor of the truck, right? All the vehicles you're going to use that will inherit, it needs to have the items that the parent class needs, right? So it will be provided. And then what you got to do here, you have to say something like, you got to say, vehicle.init, right? You're going to call that method vehicle.init, right? And then here you need to pass in self. You need to pass in these three values as well. Now you see, take that out, right? Now you see that in my truck constructor, right, these values are being passed by from outside the class, and then I'm setting the values that belongs to the truck, and whatever belongs to the parent class, which is the vehicle, I'm sending it to the parent. Now, if I run this, would it work? It probably will not, because I'm not providing those values right here. I need to provide those, right? So what does it want? It wants a model. Let's just put what model should be? Ford, right? Ford, and then the actually model F-150, 150, and then here be Ford. Color is a white. Okay, so I'm going to run this, and then right. Oh, actually, so I'm passing the information, but I'm not seeing it. I'm not seeing being printed. So what I need to do, I can take this describe vehicle, and in my describe, I can say truck information. I can say vehicle dot describe. See that? Now, running this piece would hopefully give me describe vehicle is missing. Describe vehicle is missing one very critical argument, which is called the self. Here, I'm glad it gives me some good error and says, right, it has my truck information, and it has the other information that belongs to the, actually it has the vehicle information, and it also has the truck information. So you see, this is the concept of how you can use inheritance. All right, this is how you use inheritance, being able to share, not share, but use, in an efficient way, properties that relate to different classes, such as this example. All right, so that's inheritance, and then let me see what else I got. Okay, the other thing you want to know, the whole idea of protecting. How do you go about protecting these? Anything? How do you go about protecting it, right? And then in Java we have private variables. I don't think in Python we have private variables, right? The only way you protect any members is by using the underscore variable. So let's just say I have in my truck class, right? I have another variable called VIN, right? VIN is a vehicle identification number, VIN. And then what I'm going to do here, I'm going to create a self dot, watch this, right? Watch underscore VIN. VIN is equals to VIN. What that means is that this value underscore VIN, right, will not be accessible from outside, right? It should not be accessible. Because it's protected, right? So now what I'm going to do is that, of course, I have to provide, when I run my code, I need to provide an extra VIN. So I'm just going to call it ABC 1, 2, 3, right? Now I have that, and then and let's just say I want to access the VIN here, so I can say print VIN truck one dot underscore VIN. Let's just see what happens. I mean, I would hardly do anything, right? So this allows me to access the property of the truck, right? All right, so according to our discussion, right, and we didn't expect this to show up, correct? I mean, I was expecting it to give me a problem and say, hey, it's not accessible. And what I didn't realize is that, you have to, in order to protect it, you have to use 2 underscores, right? 2 underscores, right? Now, if I run this, hopefully it will say that, hey, I cannot run it anymore because of attribute error, right? Because it's protected. So the only way to fully protect variables in Python is if you need to, you can use a double underscore, such as in that way. Right. So I think, I'm trying to think if there's anything else that would be helpful in this case, but just think, normally it's really good. It's really good to, before you creating Python, creating objects and classes, it's always very important that you start looking at how to drawing it out, what the class properties will be, what the method is going to be, what it's going to do, and then it's very easy, right? Then you just go ahead and then call those methods. Okay. So, and I'm going to do another example. In this case, you will see it's a very simple example, but I want to show you how various things can do various, various methods can do various things. So I'm going to say class here. Let's just do add. I mean, this is just simple as you can get, simple. And here I'm going to do a definition or define, not definition, define in it. And let's just assume this is taking 2 numbers, right? X self, X and Y. Simple as that, right? And then self dot X is equals to X, and then self dot Y is equals to Y. Simple, right? And then I'm going to do another method here called define. I'm going to do add, right? Or addition. Maybe addition is better name. Of course, self, and doesn't take anything else because I have what I need. And I'm going to say return self dot X times plus self dot Y. Simple, right? Now, also what I'm going to do the same thing for let's just say a multiply product, right? Product, instead of add, I'm going to call it mult and X. Okay, these stays the same, and this piece only takes it together. Okay, mult, and then I'm going to have another one, and let's just say here I want to have same thing here. I'm going to call it square, SQR. That means this will take only one value, and basically it will return to me the square of the value, right? And self, so this will, so in Python, there's a couple of ways you can do square. You can simply do, self dot, this is in this case, you can do that. You can do the math dot power, or you can do the double, you can also do something like, X to the power 2, that will work too. But this okay. So now I have my three classes, right? And I'm going to show you what I mean by when I say exchange values. So let's just say I want to create, right? I want to well, okay, let's just say I have a rectangle, right? I have a rectangle. Oh, triangle whose size is, let's just say, well, there'd be a square, right? Square. Okay, let's just keep it square. So it's a rectangle cube, not cube, prism, right? Prism or a cube, and the width times, well, no, let me just make something up here. This is not going to work. So basically, I'm going to say A is equals to add, right? And I'm adding some numbers here, and I'm going to provide 4 and 5, right? And then I'm going to say, right, I'm going to take that A, and I'm going to say M is equals to multiply. I'm going to multiply A, whatever A, actually not multiply, but A, I'm going to multiply A dot addition. Actually, this should be product, or multiply. Let's put multiply, and this should be SQUARE, square. So I'm going to take A addition, the result of that, right? I'm going to take the result of that, right? And I'm going to pass another value here, 89, right? So that will multiply the both. And then what I'm going to do is I'm going to say S is equal to SQR, all right? And in there, I can say M dot multiply, right? Multiply, so multiply, and that's it. So then I can say, I mean, I don't have a, well, maybe I can, I don't have a display method here, but square, right? M dot multiply, and then I can say print S dot square, right? So hopefully this works. Let's run it. All right, it's complaining about this track stuff that I got from before. So I know it's complaining about. It's complaining about this line of code. Take this out, right? Run it again. All right, something's going on. So let me check it. Add, right? This should be okay. I'm providing 2 values here, right? And that should set it up. And then A dot addition should do this and return to me a number, right? And likewise, whatever it returns, I'm going to supply that to my multiplication method, right? And that should take these two. Then and then my square needs one variable, and that should give me M dot multiply, right? And then that should set up S, and then, oh, I'm missing square. That's what I'm missing. All right. So it printed that out. That's 641,000. So you see what I'm doing here is that I have many classes. I mean, few classes, and they're all doing something, right? They do some kind of equation or processing, and they return values back to me, and I'm using those values and sending it back into another class. All right. So a lot of times you will have to do something like this. So hopefully this recording helps, and good luck with learning in your assignments. Have a good day. Thank you.